Now finding square root of a complex number. Okay, so this is any complex number here. A plus ib form minus 15 minus 8i, and we are looking for finding square root of this complex number. That is our assignment here. So obviously if this is a complex number, its square root ought to be a complex number only. All right, even this will be a complex number. So we are assuming let under root of this complex number be some other complex number x plus iy. Okay, so now we've got to find this x and y to come to know under root of this complex number. Okay, now what are we doing in the next step is we are squaring both the sides. So the root goes from here and this becomes a whole square. Now if you open this whole square, for the real part you get x square, that's from a square. Then if you do b square, I square will become minus 1, so this becomes minus y square. This whole is your real part. Imaginary part आएगा इनका product term. Okay, that is 2ab. So 2xyi. Okay, all of you know how to open a plus b whole square. Now comparing both the sides, this was your real part minus 15, and from here real part is x square minus y square. So that is one equation we get. The other equation you get from here, equating the imaginary part, that is 2xy, which would be equal to the imaginary part here is minus 8. These are your two equations. Okay, now another thing that you need to do is you just have to solve these simultaneously. अब इनका simultaneous solution में एक additional factor है. One is you could have substituted y from here in terms of x, and but that will make your calculations complicated, as well as there is this sign of this equation that we utilize to come to our final conclusion that you'll see just now. Okay, so you leave this equation as it is for the time being, and we also proceed to find this value x square plus y square. यहाँ हमारे पास x square minus y square था. Now we are finding x square plus y square also to be able to proceed further to find our x and y. Okay, for this we have used the identity x square plus y square. Since we already knew value of x square minus y square and 2xy, so हमने इन दोनों की हेल्प से इस एक्सप्रेशन की भी वैल्यू निकाली है, connected by our identity. If you find x square plus y square's whole square, that will have x to the power of 4 plus y to the power of 4 and plus 2x square y square. Okay, अभी इसका होल स्क्वायर अगर आप ओपन करते हो x to the power of 4, which is here also बैलेंस हो गया, plus y to the power of 4 here also balanced, and then you'll have minus 2x square y square here, but we wanted plus 2x square y square for this whole square. तो उसके बैलेंस के लिए यहाँ पे हमने plus 4x square y square रखना है. Okay, or the other way around you can understand this as that if I open this becomes 4x square y square, and if I open this you'll have a plus minus 2x square y square. So minus 2 plus 4 gives you plus 2x square y square. तो ये फिर further identity बन जाएगी of x square plus y square's whole square. Okay, so hence we can write x square plus y square as under root of x square minus y square's whole square plus 2xy's whole square. You can open and simplify this and you'll automatically get this solved equal to this. Okay, if still you're not following what I'm trying to say. Okay, you can open it and check it yourself. All right, now we already knew value of x square minus y square. Put that value from this equation. Square है तो negative positive हो गया 15 square, and value of 2xy 4x square 4x square y square can be written as 2xy whole square, and we knew value of 2xy as minus 8, so 8 square. Now the Pythagorean triplet 15 8 के साथ 17 आता है, or you can do your calculation and check. So under root of this will come out to be 17. So we have got value of x square plus y square as 17. Call it equation 3. Now we will solve this equation that we had in hand earlier. X square minus y square is equal to minus 15 with x square plus y square is equal to 17. Elimination method. Add these two equations. Minus y square plus y square cancelled. X square plus x square adds up to give you 2x square. Minus 15 plus 17 gives you 2. Solving it further to find our x, dividing by 2. This becomes x square is 1, or x is plus minus 1. Okay. Now we'll find y. तो y के लिए आप minus कर दो. If you added, you got x. अगर minus करोगे, this minus this. So x square minus x square cancelled. Y square minus of minus will make this also y square. Y square plus y square, that gives you 2y square, and 17. This will become plus on subtracting, plus 15 which is 32. So y square is 16. So y plus minus 4. Whenever we are taking root on our own, we've got to consider both the signs plus and minus. Okay. तो x and y की वैल्यू हमने यहाँ से evaluate कर ली है. Now is our turn to focus on this equation. Okay. अभी इसमें क्या था? 2 into x into y. x और y दो वेरिएबल्स मल्टीप्लाई हो रहे थे and product came out to be negative. What does that suggest? If product of two numbers, 2 तो positive है, clearly दिख ही रहा है. Product of these two numbers is coming out to be negative. So whenever the resultant is negative, they have alternate signs. एक positive होगा, एक minus होगा. So because of that, what we conclude is here that since product of x and y was negative, x and y should have opposite sign. तो अगर आप x को +1 लोगे तो y -4 लोगे. अगर x को -1 लोगे तो y +4 लेना पड़ेगा. Okay, and अगर ये positive होता, suppose in any question you come across as 2xy positive, then you will consider similar signs. X positive, y also positive. Second option, if x negative, y also negative, because negative negative also makes it positive. You understand? तो ये sign यहाँ पे plus minus sign में से कौन सा sign हमें pick up करना है, वो depend करेगा इस equation में जो हमने बीच का छोड़ दिया था. Right? So for this particular question, now we would conclude that opposite signs are रहे हैं. So therefore, our question was to find under root of this. X we had evaluated 1 आया था, तो y के मैंने -4 लेना है. X को अगर -1 लूंगी, y को plus लूंगी. Get that? So these two will be the square root of this complex number, which obviously have to be complex numbers. Alright? Now on the same line, let's take up one more example to clarify things, and that is now we are looking for finding under root of 1 minus I, which would be another complex number, suppose x plus iy. Squaring both the sides, that's what you end up getting. Comparing real with real, imaginary with imaginary, two equations with the help of which we will cook up our third equation, which would be x square plus y square, जो automatically हमारा क्या आता है, अभी हमने ऊपर पूरा proof करा था, यहाँ पे हम cut short कर दे रहे हैं, as this square plus this square. Alright? x square minus y square is whole square था and plus of 2xy का भी whole square था. So whatever is this number square plus this number square. So we have evaluated value of x square plus y square as root 2. Next is eliminating एक बार x की value एक बार y की. तो adding the two equations you get this was 1 and this was plus root 2. Dividing by 2, I've cut it short and taking the under root. So plus minus of 1 plus root 2 upon 2 इसका under root. तो double root आ रहा है, no problem, leave it like that, write it like that. Alright, then minus करके y square की value, with the help of that y will be evaluated. So root 2 minus 1 upon 2's under root. x y दोनों आ गए. Now again we have to decide for कि sign हमारा x into y का क्या था. So from our second equation again x y was negative, तो हम alternate signs लेंगे. Positive होता तो हम same signs रखते हैं, या both negative or both positive. So for this again you will take alternate signs. So how am I going to present it, because expression थोड़ा complicated सा था, तो ऊपर वाला फिर भी easy था हमारा. So this time we'll write it as, this was the x that was evaluated minus y, because हमें पता है alternate signs आने, तो ये positive है तो ये negative होगा, and I've put plus minus sign in right in front. Okay, so one solution would be plus of this and minus of this, and in the other one if you take this negative, then negative negative, second one automatically becomes positive. So we can combine and write both the answers. Okay, and y, of course I has to be written there. So under root of 1 minus I would come out to be this bit. Alright,